All right, solving equations with rational exponents. A rational exponent is just an exponent that is a ratio or a fraction. So for example, if I have x to the 2/3 power, this numerator is our exponent or our power, and the denominator represents our root. So you could rewrite this as the cube root of x squared. And it's important to know that it doesn't matter if you place your exponent under the radical or on the outside. I've got it placed on the outside right now. You could also say the cube root of x squared like this. They sound the same. You say it the same way. It's just the placement. And either way is fine. You get the exact same solution either way that you write this. Sometimes it's easier to simplify one way over another. All right, so let's look at an example. We have n to the 3/2 power equals 125. So if you remember your exponent rules when you're solving equations, if you have one power taken to another power, you just multiply those two powers together. Well, what's the only value that I can multiply 3/2 by to turn it into the number 1? And that's just its reciprocal. The reciprocal of 3/2 is 2/3. So let's take this side of my equation to the 2/3 power. That's the reciprocal of 3/2. And so my equation stays balanced. I go ahead and I take the right side of my equation to the 2/3 power as well. So now when I have these two exponents, one power taken to another, they multiply to make the number 1. They reduce. So this ends up giving me just n. So I have n equals. Now the right side of my equation I can simplify also. So let me rewrite it first. Our root is the number 3. This is a cube root. So the cube root of 125, and then our numerator was a 2, so it's being squared. And I would choose to write it this way because I see over here, I wrote some perfect cubes down for us. I can see that I can simplify the cube root of 125 pretty easily, right? 5 to the 3rd power is 125, so therefore the cube root of 125 is just 5. So this is the same thing as saying n equals 5 squared. It would take a lot more work for me to square 125 and then find the cube root. So 5 squared is equal to 25. And you always want to go back to your original equation, substitute in your values, and make sure that you don't have any extraneous solutions. So if I go back to my original equation right here, let's substitute in the number 25 for n. So 25 taken to the 3/2 power should equal 125. Well, this is the same thing as saying the square root of 25 cubed should be 125. Well, the square root of 25 is just 5, so 5 cubed should equal 125, which of course it does. So n equals 25 is our solution. So let's try another example. My daughter's waking up. Let's try 2x minus 1 all to the 2/3 power equals 16. Okay, so I already have this expression right here isolated, okay? My rational exponent applies to everything inside the parentheses. So I don't need to isolate this expression. But let's get rid of this 2/3 power. So we're going to take everything to the 3/2 power, right? Because the reciprocal exponent is just 3/2. Which means I need to take the right side of my equation to the 3/2 power as well. But this is a little bit dangerous. So when you're using these exponent rules, I need to make sure that you remember anytime you take an even root to solve an equation, which is what we did right here, you have to use your plus or minus symbol. Do not forget that you could have two solutions anytime you take an even root. And that, of course, that reason behind that is another video. But just remember, anytime you take an even root of both sides of your equation to solve, you definitely have to use your plus or minus. All right, so these reduce, and you end up with 2x minus 1 equals, we have a positive 16 to the 3/2 power, And we have 2x minus 1 equals a negative 16 to the 3/2 power. Okay, so make sure that you have both of these. And so then we're just going to simplify, right? So 16 to the 3/2 power, what does that give us? Well, that's the same thing as saying the square root of 16 cube. All right, so 2x minus 1. The square root of 16 is just 4, so this is 4 to the 3rd power. 2x minus 1 equals 4 cubed is 4 times 4 is 16, times 4 again is 64. So let's add 1 to both sides of our equation. And we end up with 2x equals 65. So of course, x equals 65 over 2. That's one of our solutions. Now let's do the other side, or the other solution that we could have. We have 2x minus 1 equals negative 16 to the 3/2 power is like saying negative, and then we have the square root of 16 taken to the 3rd power. Well, the square root of 16 is still 4, so this is like saying negative 4 to the 3rd power, right? So this is 2x minus 1 equals negative 4 cubed is like saying negative 64. Add 1 to both sides of our equation. And of course, that gives us 2x equals negative 63. Divide both sides by 2, and we get x equals a negative 63 over 2. Phew. All right. So we have our two solutions, but we've got to check them both. And I know that seems labor intensive, but you know what? It's got to be done. So our original equation, don't forget, was 2x minus 1 to the 2/3 power equals 16. So let me write that down. 2x minus 1 to the 2/3 power equals 16. That was our original equation. So let's substitute in the 65 halves first. So I have 2 times 65 halves minus 1 to the 2/3 power should equal 16. And when I multiply 2 times 65 halves, those reduce. So let me go ahead and reduce those. So I've got 65 minus 1, which is just 64. So I have 64 to the 2/3 power. So the cube root of 64 squared should equal 16. Well, the cube root of 64 is 4. So 4 squared should equal 16, which it does. All right, so let's check our second solution. We have 2 times negative 63 halves minus 1 to the 2/3 power should equal 16. All right, again, we have 2 times negative 63 over 2. Those 2's reduce. Negative 63 minus 1 is a negative 64. So I have negative 64 to the 2/3 power. So that's just the cube root of negative 64 squared should equal 16. Well, what is the cube root of negative 64? The cube root of negative 64 is a negative 4. We've got to square that, and it should equal positive 16. Well, when you square a negative, it becomes positive. So that is true as well. I want you guys to be careful. When you take a value that's negative and you're taking it to an exponent, a positive exponent, you need to make sure that you put it in parentheses, because when you square a negative, it does become positive. So make sure you're careful with your solutions. So both of these are correct solutions. Neither one of those are extraneous solutions that would make our equation false. All right, let's do one more example. I've got 115 equals negative 10 minus x minus 10 quantity to the 3/2 power. So I've got this rational exponent, so I want to isolate this expression right here. So the first thing that I need to do is add 10 to both sides of my equation. And that's going to give us 125 equals a negative parentheses x minus 10 to the 3/2 power. Now, I still have that negative. Remember, there's always an invisible 1 in front of an expression. Multiplying by 1 doesn't change anything, so we don't normally write it. So here I've got this negative out in front. So I'm going to divide both sides of my equation by a negative 1. And that just gives us a negative 125 equals x minus 10 to the 3/2 power. All right, so let's get rid of this rational exponent. We are going to take it to its reciprocal power, which of course is just 2/3. We're taking it to the 2/3 power. Notice the negative 125 is in parentheses right now because I'm taking that entire expression or that entire numerical value to the 2/3 power. And these reduce. So the left side of my equation is the cube root of negative 125 squared, and that should equal x minus 10. Well, what is the cube root of negative 125? Well, negative 5 times negative 5 times negative 5 gives us our negative 125. You can take the cube root or an odd root of a negative number. It's just the evens that we have a problem with. So the cube root of negative 125 is just a negative 5. And when I square that, it should equal x minus 10. And negative 5 squared is a positive 25, and that should equal x minus 10. And then, of course, I'll add 10 to both sides of my equation. And that gives me 35 equals x. All right, so x equals 35. That right there is our solution. Let me get that out of the way. So let's go ahead and sub that back into our original equation just to make sure it's not an extraneous solution. All right, so we have 115 should equal negative 10 minus parentheses. We got 35 for our solution, minus 10 to the 3/2 power. All right, so let's simplify this. 35 minus 10 is a 25. So this is like saying 115 equals negative 10 minus 25 to the 3/2 power. All right, what does this rational exponent mean? Well, 2 is the square root, and the 3 means we are cubing it. So this is 115 equals negative 10 minus the square root of 25 to the 3rd power. All right, the square root of 25 is just 5. 5 to the 3rd power is 125. So the right side of my equation says negative 10 minus 125 should equal 115. But when I combine both of these values, negative 10 minus 125, I get a negative 135, which is definitely not equal to 115. So none of these statements were true, and we have an extraneous solution. But because I didn't end up with 2 solutions to check, this is an extraneous solution, so that tells me that my original equation was false. There is no solution. There is no solution to this equation. Just a side note, if you guys have a graphing calculator, you might be able to use the online Desmos calculator. Anytime you have an equation and you just want to double check your algebra, let's say you're working on your college algebra homework. If you graph the left side of your equation and the right side of your equation, you should be able to find an intersection value. And whatever the x value is of your intersection, that should be your solution. So if 115, the graph of 115, does not ever intersect this graph right here, there is no solution to this equation. Just a little side note, a little trick that you can always use to check your work quickly if you're working on a bunch of homework problems for practice. All right, I hope that helps.